This lesson is on the exponential rule for derivative shortcuts. And so when we think of exponentials, we think of y equals a to the x, or a number to the x power. And I've put e to the x over here, but e to the x is really the same thing as a to the x because e represents a number. It just happens to be a very long decimal. So the derivative rule for this is that the derivative is that same thing, you copy it down, but then you multiply by the natural log of the base. Now, the reason I have the e to the x over here is because what happens when you bring it down and then you multiply by the natural log of the base, well, the natural log and e kind of cancel each other out. They actually become 1. And so you just have e to the x. And so basically anytime you want to take the derivative of e to the x, it's just e to the x. Whenever the exponent is not a plain x, so in these cases I just have a plain x, you have to use the chain rule, and I'll show that to you in our examples coming. Alright, our first example is the most basic, y equals 5 to the x. So the derivative would be 5 to the x times the natural log of 5, because we would multiply by the natural log of the base. I don't have to do any chain rule in this case because the exponent is a plain x. Example 2, I will be doing the chain rule because the exponent is not a plain x. So I would start with my rule. You copy exactly what you have. So 3 to the 2x cubed power. You multiply by the natural log of the base, which is 3. But then this exponent being different means you multiply by the derivative of that exponent. So if you just had 2x cubed, its derivative would be 6x squared. So again, with the exponential, you copy it down, you multiply by the natural log of the base, and then you multiply by the derivative of the exponent. Okay, example 3, we have e to the 4x. So this is something other than a plain x. I'll be doing the chain rule with it as well. So my derivative would be, copy that down, multiply by the natural log of the base, but I don't have to put natural log e if I don't want to. If you do, I won't count it wrong, but it's going to cancel out eventually. And then we would multiply by the derivative of the exponent. Derivative of 4x would just be 4. Okay. In example 4, I have something a little different. I have a coefficient in front, this 2. And what happens when it's just a plain number and there's no variable with it is you just bring it down. So your derivative will be 2. Then you do the regular exponential derivative rule. So bring down the 3 to the 5x squared. You haven't done anything here but copy down. Then, since it's an exponential, you multiply by the natural log of the base. The base is the 3, not the 2, because the exponent applies to the 3. So natural log of 3. And then, because the exponent is not plain x, we would multiply by its derivative, which would be 10x to the 1. Well, we don't normally put 1. Okay, in example 5, before you take the derivative on this one, you have to turn this 1 over the square root of t into something we can work with. So I'm going to rewrite the problem, and this will be written as t to the negative 1/2, because anytime you have fractions or roots, you want to turn those into powers. And this is just a mixture. This is still your power rule that we learned the other day. This is your exponential rule. This is another situation where you have a coefficient, so you just bring it down. This is your exponential piece, so you copy that, multiply by the natural log of the base, but again, we don't typically write natural log e because that's going to be a 1 anyway. And I don't have to chain rule because the t is plain. Then I bring down the minus, and I do the rule for the t to the negative 1/2. And so that would be a negative 1/2 t. And then negative 1/2 minus 1 would be minus 2/2, so you get negative 3/2. Now, because this is a double negative, I would probably want to combine that and put plus 1/2 t to the negative 3/2. Alright, example 6, I have this very long string of things because people get confused when you're using e's and pi's and they don't think of them as numbers, but they are numbers, and so you need to remember that. I mean, treat them as if it were like 3 or 2. E and pi is a number, or are numbers, excuse me. So let's think about what's going on. E to the pi is a number to a power that is a number. So this is a number, and the derivative of a number is 0. It's just like having a horizontal line. The slope of that is 0. Then pi to the e. Pi is a number, e is a number. A number to a number power is a number. So this is also a plain number. And so the derivative of that would be 0. X to the e. X, you finally have a variable. E is a number. So just think of it like, hey, what if I had x squared? What would I do? You would do a power rule. So you would bring that to the front and then subtract 1 from the power. The next one, x to the pi. Yet another time where it's x to a number, like if it was x cubed. It's a power rule. This is a power rule situation. So you bring the pi to the front and subtract 1 from the power. Next, e to the x is the exponential rule that we're learning today, and the derivative of e to the x is e to the x. And then finally, pi to the x is also the exponential rule, so we copy that down and multiply by the natural log of the base, which in this case is pi. So these are popular types of questions, or mixtures of these, because people get in the habit of doing either a power rule or an exponential rule, and they don't recognize when something is just a number. And so think of each piece individually and separately and ask yourself, is this a power rule, is this an exponential rule, or is this just a number? Okay, and then our final example is kind of complicated looking. The first thing I'm going to do is turn this fraction into an exponent. So I'm going to rewrite this. I'm not taking the derivative yet, so I'm not putting a prime, as e to the 3x over 2, or you could write that as 3/2 x, because it's just a number times x. And then minus, I'm going to put 1 minus e to the negative x to the negative 1 power, because it's on the bottom of a fraction, and I want to deal with my fractions as exponents. Okay, then I'm going to take my derivative, and for the first one is your exponential rule, so you copy it down. Again, the natural log of e would cancel, so I don't have to write it. And then the derivative of 3/2 x would just be 3/2, so multiply there, it's the chain rule. Then I'm going to bring down this minus. And I have to do a chain rule here. I have to do the derivative of the outside and then multiply by the derivative of the inside. So put your thumb over the parentheses here and think about what happens here. I would have -1, big parentheses, to the -2. Keep the inside exactly the same. And then multiply over here by the derivative of the inside in its own set of parentheses. So the derivative of 1 would be 0. I'm not even going to write that. I'm going to bring that negative. I'm going to copy the e to the negative x. I'm not going to write down natural log of e, but you could. And then I'm going to multiply by the derivative of negative x, which would be -1. And yes, there's lots of simplifying that I can do here, but for right now, we're just taking the steps to get to the final derivative. And if you leave it like this, I can see if you've made a mistake, if you can't figure out what you've done and whether it's right. Okay, that concludes this lesson. If you have any questions, please raise your hand.